Hi everyone. Good afternoon, guys. Right, good afternoon or good evening, whatever it is. Right, so here we'll be continuing our discussions on which one this SOM Quick Revision, right? Strength of materials, Quick Revision. We'll be continuing, you can say. And if you remember, right, what is that we have discussed in the previous classes? If you just consider. So what is that we have discussed in the previous classes? If you just say, right, up to this stress strain curve of this mild steel we have done, na? Yes or no? So what is it we have done? You can say stress strain curve of this mild steel we have done. You can say, and we'll be continuing from that. Okay. So this is your SOM quick revision. All of you, welcome to Unacademy. Let's crack it, right? Everyone, get ready to crack, all of you. Right, get ready. So here this is my profile, you can follow me at which, and uh, what is the referral code you have to use, right? RP Civil is the referral code you have to use, right? Now these are all, which one you can say, these are all AIR ones, right? Those who are secured AIR 1 from Unacademy in GATE 2024 from various branches of engineering, you can say, yes, no? Right. So this offer, right, freedom to learn and this freedom to succeed offer, it is extended up to which one? Up to this 18th August, you can say. So that the gate subscription plus subscription now at 8,499 only available, right? Don't miss this. You can find all the details in the description of this video, all of you, right? Now coming to this, this targeted, whenever you are targeting for 2025, you can take this, which one? This is 6 months subscription plus subscription at 8,499, and you can take, if you want, you can take, if you want additional benefits like extra printed notes and mentorship, right? All these things if you want, right, you can take which one? This is a iconic subscription, right? That too for 6 months it will be available at 14,999, right? So what is that referral code you have to use? Tell me. RP Civil is the referral code you have to use, na? So no, RP Civil is the referral code you have to use, you can say, is na? No. Here these are the latest batches starting, right? What are these latest batches starting? Tell me. So this Pratishta batch for this 2025 aspirants, right? Pratishta batch will be starting for which one? This 2025 aspirants. It is starting on 18th August, right? That is tomorrow. Don't miss this, all of you. And irrigation engineering by KP sir and structural analysis by Abhishek sir will be starting, you can say, right? What is that referral code you have to use? Tell me. RP Civil is the code you have to use, right? Shikhar batch for this 2026 aspirants will be starting from 18th August. So irrigation by KP sir and structural analysis by Abhishek sir, right? You will be having. And what is it? A referral code, right? RP Civil is the referral code you have to use, right? When you are taking iconic subscription, you will be getting these books delivered to your home within 15 days of your subscription, you can say, right? All these books, printed books delivered to your home within how many days? If you just upload, within 15 days of your subscription, right? Now, so this is first class over, that stresses mechanical properties we have discussed. The second class, right, what is it you can say, that is stress strain curve we have done, is no? Stress strain curve for this mild steel we have done, right? Up to 19 points it's over, right? So now today we'll be discussing which one? This is lecture 3, that SOM quick revision. Stress strain curve will be continuing, and what is it you can say, true stress and strain, and this elongation will be going for, right? Is no? Yeah, Pavan, good evening. So here this is your first point, you can say, if you just right. So now 19 points gets over now. Previously if you just observe, this is your which point you consider, that is your 20th point na? So no, that is your 20th point, you can say, right? So in case of this stress strain curve also, right, what is that you are having, right? Do you give guarantee that for all materials you will be getting the exact yield stress location? So in case of this mild steel, upper yield point and lower yield point are separately given, right? We can find out that, right? But here, what is it you can say? In case of all materials, right, we'll be getting like that, or we may not be able to get in all materials like that, you can say. In case of all materials, right, we may not be able to get it like that, na? Yes or no? So then in that case, right, what is it we need to do? There is no yield point, clear visibility of this yield point available, right? So then what is it you can say? Then how can you find out this yield stress? You can say you can find out the yield stress in this manner, right? What is it you can say? Yield stress we can use, right? What is it you can say? Stress strain curve for which one? High carbon or this aluminum alloys, na? Stress strain curve for which one? This high carbon steel, or you can also call it as which one? This aluminum, which one? This alloys. Aluminum, which one? These alloys, you can say, right? So if you are having this stress strain curve like that, right, how can you get that yield stress? If you just observe, this is your stress on this y-axis and strain on this x-axis, you can say, and what is that you are having is, right, you will be getting the curve in this manner, right? Now in this curve, can you able to differentiate that upper yield point and this lower yield point clearly? Is it possible or it is impossible? You can say, right, it is impossible, no? So then in that case, right, what is that we need to do? We have to find out in another manner, right? How can you find out? You can say, if you just observe, how can you find out? If you just observe, you can say, how can you find out? If you just observe, how can you find out, right? Because if you observe in the mild steel, na, so there what happens in the mild steel? If you just observe in the mild steel, it happens that, right, what is happening in the mild steel? You can say in the mild steel, right, it is happening that, so at this 0.2 percentage of this strain, na, so that will be losing its elasticity, right? It will become plastic, right? Means what is that? You can say yield point, right? That yielding is occurring at this place only, no, right? Yielding is occurring at this place only, right? That adjustment of this member, adjustment of these particles and everything is happening at that place only, right? So that is why what we'll do, so initially you will be having some little bit straightness, na, isn't it? So to the initial straight portion, right, we draw a line and intersect that at to the main curve, right? So that intersection point will be taken as which one? This yield stress Fy, right? So at which one we have to go for, right? At this 0.2% strain only we have to draw a parallel, right? What is this called as, right? This is called as your proof stress, na? This is called as your proof stress, you can say, right? Proof stress means, right, it is derived or it is directly observed or it is proved or this derived, you can say. It is not directly observed, no, it is proved or this derived, you can say, right? That is why you call this with which name? If you just observe, proof stress, right? You call it with which name? You can say you call it with the name proof stress. If you just observe, right, like that, isn't it? Is it clear why you are calling it as proof stress, right? Now that yield stress we can find out, right? Yes, na? So this is offset yield point, right? What is that? You can say this is called as your which one? Offset yield point, na? Whenever somebody is mentioning it as this offset yield point, right, this we have to mention it as this offset yield point or not, right? Offset yield point, you can say, right? Yes, na? Now, so what are the other stress strain curves, you can say? That is stress strain types of this curves, right? What is it? You can say in general, na? In general forms, right? What are these in general forms? You can say, suppose if you are having in this manner, right, what is it? You can say this is exactly the straight one only we are having, that is stress strain curve. So what it is, you can say this is your linear elastic or not, right? That is your which one? This linear elastic, is not linear elastic, right? And suppose if you are having this, right, that is your stress strain curve, you can say this is your which one? This is stress strain curve. If you just observe it, what is that you are having here? So if the curve is in the vertical manner like this, right, what it is, you consider this is your rigid, na? So because whatever the stress you are applying, right, do you have any strain or no strain? No strain, na, right? Whenever there is no strain, you call it as this rigid or not, right? You call it as this rigid, you can say, right? Suppose if you are having this curve like this, right? So this is your stress and this is your strain, right? What is that you can say? It will be which one? If you just separate, it will be which one? This in this manner, na? So what is it you can say? This is your rigid plastic. That is your which one? This rigid plastic, na? So no, rigid plastic, you can say, if you just right, because first rigid will be there, then after that, right side plastic will be there, na? Rigid plastic, if you just consider, right? Got it? Suppose if it is like this only, simply this is your stress, this is your strain, and we do not have any stress applied, but what is that we are having, right? Only that a strain is present, right? Then you can call it as which one? This is perfectly plastic, na? Then this is your perfectly plastic or not, right? Can we say this is your perfectly plastic type if you just consider, right? Yes, now can we say like that or not, everyone? Can you say like this? Perfectly plastic, you can say it, na? Perfectly plastic, you can say it if you just observe, right? Next, what is another one you are having? You can say noted. These points are noted. Come on, and others. Don't tell me. Hi, sir. Good evening, sir. Yeah, Pawan done. So this is what the different. Yes, yes, I am good, sir. How are you? Right. So these are different types, and what are the other types you can have for this stress strain curve? The combination, if you see, so what is the combination? Right? This straight inclined linear, right? What is that inclined linear? You can say this is your elastic, na? And plastic means, right? What is it? You can say exactly horizontal, right? That is your plastic, right? So it is a combination of which one? You can say it is a combination of, yeah, no, no, no. It is perfectly plastic. Plastic means, what is the meaning of this plastic? Like a water, you can say. Without applying any load, it will be having the deformation, right? Then it is called as your plastic. This first one is what? A linear elastic, or this perfectly elastic, you can say first one, right? So it is a combination of this first and this last. What it comes to be? Elastoplastic, no? So that is your linear elastoplastic or not, right? Linear elastoplastic. So it is linear means straight line variation only, and elastoplastic, right? Elastic behavior will be there up to this, and after that followed by this plastic behavior, you can say, yes, na? Isn't it? Now, do you give guarantee that always it should be linear only to have this elastic conditions? No, it need not be, right? Suppose if you are having this one, what is this? You can say inelastic also, right? Sorry, non-linear also, right? Loading and unloading path are exactly same. When this loading and this unloading path are exactly same, so can we say it is elastic or it is plastic? You can say loading and unloading paths are exactly same means, do we have any permanent deformations or no permanent deformations are present? You can say no permanent deformations are present, or no permanent deformations are present, right? It is exactly elastic only or not, right? So you can call it as which one? This is a non-linear elastic, na? Elastic only, but it is linear or it is non-linear, you can say, right? Non-linear condition, you can say, right? Non-linear elastic, if you just observe, right? Got it now? Non-linear elastic, you can say, right? So now if you just consider, right, what is it? You can say this one. This is your stress, this is your strain, right? Up to this, what is it you are having, right? Linear, you can say. If it is rising afterwards, right, what is it? You can say first portion is representing that elastic, and second portion is representing which one? This is strain hardening or not? Strain hardening, right? In your mild steel stress strain curve, do you remember this portion? Do you remember this portion? This EF portion is called as your strain hardening only, no? Right? This rising wala portion, right? This portion, if you just observe. So this falling wala portion, right? FG will be called with which name? Necking zone, or you can also call it with which name? You can say that is also called as your strain softening, na? That is also called as your strain softening zone, you can say, right? Exactly opposite to the strain hardening, it is strain softening, na? Isn't it? Right. So this is your which one? This elastic strain hardening or not, right? Elastic strain hardening, right? Now if you just consider this, right, this is your stress, this is your strain, and how the curve can be present, if you just observe, you can have the curve like this. So this is vertical first, right? Whenever it is a vertical one is there, right, what is that? You can say vertical line is there means it is your rigid, na, zero strain or the zero deformation, and after that it is rising, right, like this, right? So can we say it is your rigid strain hardening? it is nothing but your rigid strain hardening or not, right? Rigid strain hardening, you can see if you just observe, right? Now what you will be having after that, right? This is your stress, this is your strain. So what you will be having, you can say this is your linear elastic, and after that it is a falling, you can say, right? Falling means a strain softening, na, is that no? So that is your, which one you can say, linear elastic. Linear elastic, what is it, you can say, linear elastic. Linear elastic. And what is that? This you can take it as this necking, you can say. But linear elastic necking, right? In another manner, right? How can you take this? This is your stress strain. Similar to this only it is present, right? Like this we are having straight line, but it is exactly in the vertically downward, right? What it is, you can say, this is your linear elastic necking means, right? Linear elastic necking means linear elastic that is strain softening only, no? Linear elastic that is strain softening only, no? Necking is nothing but your, where the neck is starting at the strain softening condition only, no? But it is exactly in the vertically downward instead of this right side. This is called with which name, you can say? Yeah, this is called with which name, you can say? This is your linear elastic, and which nature, tell me? Linear elastic yielding, na? First straight line is linear elastic, right? After that it is yielding if you just avoid. Here stress strain curve. So this is going in the vertically downward direction directly, na? Vertically, exactly vertically downward direction. But here it is inclined direction, right side it is moving, na? Softening. But this yielding condition, what is it, you can say, after this upper upon rate, it is exactly in the downward direction, na? Vertically downward direction. Got it? Why it is taken as this yielding if you just observe? Clear now? No. So if you just go for this one more curve, that stress strain curves, everything will get over. So in majority of the examinations, right, directly you will be getting this, and they will be asking it, you can say, right? So here if you just observe, what is that? So here this is your, which one, this first rigid, okay? It is rigid, and after that, right, what is that you are having, right? Like this you are having, right? What it is, if you just observe, what it is, you can say, if you just observe, first rigid will come, yes, na? First rigid will come, right? Similar to this, do you have the rigid? First rigid will come, right? Then after that, right, what is it, you can say, rigid non-linear plastic, na? So linear plastic or non-linear plastic, you can say, it is your non-linear plastic, na? Non-linear plastic, if you just write like that. Is it clear? So these points, so this 21st point gets over, right? Yes, na? Now 22nd point, if we just consider, right, what is that 22nd point, you can see, if you just say factor of safety, right? Whenever it is mentioned as this factor of safety, what is that factor of safety, you can see, if you just observe, that is your yield stress divided by which one? Yield stress divided by this working stress, na? Or permissible stress, right? Working stress or this permissible stress or not, right? This is for which material, tell me? This is for this ductile material, na? This is for this ductile material, right? Now this factor of safety will be taken equal to, right? In case of this brittle material, do you have any permanent deformation, long deformations possible, or you will be having directly that breaking only in case of rigid material, tell me? If it is, sorry, if it is a brittle material, if it is a brittle material, right, you will be having this direct breaking only, no, right? You will find much deformations, or you don't find much deformations, tell me, right? You don't find much deformations, no? Isn't it? You don't find much deformations, right? So here yield stress comes into picture, or ultimate stress comes into picture, tell me, if you just observe which stress comes into picture for brittle material. Ultimate stress comes into picture, na? So no, that is your ultimate stress comes into picture, you can see, if you just observe, right? Isn't it? That ultimate stress divided by which one? Same working stress only, na? Isn't it? Working or this permissible or allowable stress, you can say. This is for which material? That is for your brittle material, na? That is for your brittle material, you can say, right? Now what is that margin of safety, if you just observe? FOS is nothing but your factor of safety, right? Margin of safety is nothing but which one? Factor of safety minus 1, na? That margin of safety is given as which one? This is a factor of safety minus 1 only or not, right? Margin of safety is nothing but your factor of safety minus 1 only you will be having, you can say, if you just consider, right, like that. Isn't it clear? Margin of safety is nothing but your factor of safety minus 1 only comes into picture, right? Is this point clear up to this point? Is it clear up to this, everyone? The relation between this right. So now if you just consider, right, what is that a true stress strain, you can say, what is that a true stress strain, if you just observe, true stress and strain, right? What are this a true stress and this strain, you can say, this a true stress and this strain are based on what? These are based on which parameter, if you just observe, these are based on the actual area, and actual dimensions, no? It is based on which one? This actual area and this actual dimensions, yet the time of measurement, na? At the time of which one? This measurement only, or not at the time of this measurement, you can say. So actual, when you are calling it as, means that it is a true only, no? True is nothing but your actual, or it is a false, you can say. True is nothing but actual only, obviously, na? Originals, right? No duplicates. Yes, absolutely, right? Originals, right? No duplicates. Now if you just consider this, what is it, you can say, engineering or this nominal stress and strain, engineering stress and strain, or this nominal stress and strain. So this engineering stress and this strain, or this nominal stress and strain means, right, these are based on what? These are based on the actual cross section area, or based on this initial cross section area, you can say, based on the initial cross section area, na? And actual dimensions, now with respect to these actual dimensions, sorry, not actual, initial. Okay, so initial cross section area and dimensions, simply we'll write that, initial cross section area and which one? Dimensions, you can say. Like that. Got it? Yes, no? So this is a true stress, right? What is the symbol we are giving? Sigma T is the symbol we are giving, right? Engineering or this nominal stress, right? What is that? Epsilon E we are giving the symbol, right? What is that? A true strain, epsilon T is the symbol we are giving, right? This is your engineering, right? That is your epsilon E is the symbol we are giving, you can say, right? Yes, no? Is it clear now? Now coming to this, if you just compare in case of this compression as well as in case of this tension, right, how they will be changing, tell me. This is your 25th one, right? In case of this compression and as well as in case of this tension, right, how they will be changing, if you just observe, how they will be changing, tell me. Based on what? Which one is higher? True stress is higher or engineering stress is higher, tell me. True stress is higher or this engineering stress is higher, tell me. True stress is higher or this engineering stress is higher, if you just observe, everyone. Which one is higher? So here whenever you are having this, yes or no, suppose in case of this tension, okay, we'll write it separately for this tension as well as which one, this compression, then we can understand the relations finally we'll write, okay, that is different. So now what is that, you can say, in case of this tension, na? So what is this, you can say, if you just observe, that is your A naught, na? That is your A naught initial cross section area at the starting, that P1 P equals to 0, that P1 is equal to which one, this 0, na? Initially do you have any one, or P1 is 0. After that, right, what happens, you can say, if you just observe, after some time, right, after loading is applied, right, at this P2, right, you will be having which one, this is your P2 and this is your which one, this P2, and what is this at the time, at this time of this measurement, and this is your which one, this actual area, right? Now tell me which one is higher, tell me. That actual area is higher or this initial area is higher, right? Initial area is higher than this actual area, na? So therefore, what is that you can say? True stress, right? Which one will be higher? That true stress will be higher, or this nominal stress will be the higher? Tell me. True stress will be higher, or this nominal stress will be higher? If you just observe, which one is higher? Tell me. True stress means. True stress means, right? What is it you can say? True stress means what is that? That load P2 divided by this actual area A, and nominal stress is nothing but your which one? This load P2 divided by this initial area A0, right? Which one is higher? Load is the same, A0 is higher means, so this will be higher, na? So no, sigma T will be higher, right? In case of compression rate, what is that you can say? It will be same or it will be reverse if you just observe. In case of this compression, it will be same or it will be reverse if you just consider. In case of this compression, it will be reverse, na? So in case of this compression, it will be reverse, you can say, right? Why? Because the cross section area decreases or cross section area increases, you can say cross section area increases, na? So this is your which one you can say, that is your A0 initial area, that P1 equal to 0, right? P1 equal to 0 means just before application of this any loading. Now after that, right, what happens, you can say, sorry, the cross section area increases absolutely or not, right? The cross section area increases absolutely, you can say. One sec. So here what happens, that length decreases, na? In case of compression, it length decreases, so automatically, right, what happens, that cross section area increases, na? According to the Poisson's effect, right? What is this you consider? This is your A if you just consider. Which one is higher? A is higher than this A0, na? Yes, it's hi, I'm good. How are you? A is higher than this A0 or not, right? Now tell me, sigma T will be higher or this sigma naught will be higher, you can say, right? Sigma T, what is it you can say? That is your P2 divided by this A, na? And sigma naught will be how much, you can say? That is your P2 divided by this A, na? P2 divided by which one? This A0, right? Because this is your nominal means, right? Original initial area, right? Before application of load, right? Whatever it is presented, that we are taking or not, right? That we are taking if you just observe, right? Is it right? Now which one is higher, right? This A will be higher, denominator is higher means, right? This total value will be lesser, right? So sigma T will be lesser, right? Got it now? This is how you are getting it. Which one is higher and which one is lesser in case of this compression and in case of this tension. Is it clear, everyone? Yes, na? Sigma E or this is sigma naught, right? Sigma E or this is sigma naught also we can use the symbol, right? This one also epsilon E or epsilon naught also the symbol you are using, right? Naught means nominal. Got it? Clear now? So here the relations, right? Relations between which one? Sigma T and this is sigma naught, and also which one? This epsilon T and this epsilon naught, right? Anybody can guess what is that a relation between them, right? What are the relation between them? Tell me. Anyone? That what is it you can say? That true stress will be equal to nominal stress into, right? What is it you can say? 1 plus epsilon, which one? This is not only, right? 1 plus which one? This epsilon not only, na? 1 plus epsilon not only. 1 plus epsilon not, or which one? Tell me. This is 1 plus epsilon naught, or which one? Tell me. 1 plus epsilon naught, right? So here what is it you can say if you just observe that epsilon T will be equal to log Ln is nothing but your natural logarithm, na? 1 plus epsilon T, okay? This is epsilon T or epsilon naught, right? That is your epsilon T, na? So that is epsilon T or epsilon naught, you can say. Epsilon T or epsilon naught, everyone? Somebody? Which one is correct here? You remember at these two places, right? It is your epsilon naught or epsilon T. Epsilon naught only, right? At both places, right? What is that? Epsilon naught only, right? So how can you rewrite this, right? You can write it as this Ln into what is it? You can say L true length divided by this which one? This L naught, right? Yes, na? That is also equal to which one? This Ln into reverse it is, right? Nominal area divided by which one? This actual area at present, right? If it is a circular, now you substitute the circular area, right? Isn't it? Got it now? These are the relations you are having if you just observe. These are the relations you are having if you just observe. So this is a relation between which one, tell me? These are the relations between which one? True and these nominal stresses and this strains, na? True stresses and strains and nominal stresses and strains, right? Actually, elongations we have to do, that we'll do in the next class. Okay, clear now? These points we have discussed, right? Already 22, which one? 26 points we have discussed, right? Elongations we'll see in the next class, you can say. Okay, shall I close? So I'll be closing the session. Thank you, have a good day. Thank you. Okay.